7.6, fractional exponents. We're going to combine the two radicals with fractions. So, a fractional exponent represents both a power and a root. Another way of writing the square root of a is to say a to the 1/2 power. They mean the same thing. By the same token, a to the 1/3 is the same thing as the cube root of a, or a to the third, the cube root. So therefore, a to the 1/nth power would be the nth root of a. So when we're talking about fourth roots, fifth roots, sixth roots, you can write them instead as a fraction, a to the 1/4, 1/5, or 1/6. Now to make it a little more complicated, a to the 3/2 power is the same thing as, well, you see the fraction in there, the 1/2? That's the same thing as the square root of a cubed. A to the 4/5 power would be a to the 4th under the 5th root radical sign. Keep in mind that the 1/5 represents the index of the root, and then that 4th represents what you're raising the radicand to. So a to the m over n is the nth root of a to the nth power. So let's play around with some examples. Rewrite each of it as a rational exponent. In other words, write it in fraction form. So take it as a square root type of symbol and change it into a fraction. Simplify when possible. Okay, so 10th root of x to the 6th, it can be written as x to the 6 over 10. Remember that 10th, the denominator, is going to be our index from our radical. Now that fraction can be simplified, so you could rewrite that as x to the 3/5, and that's all you have to do. Right, let's take a look at the next one. Cube root of 27x squared y cubed. Rewrite that as a fraction. That will be 27 to the 1/3, x to the 2/3, y to the 3/3. Essentially, I just took that whole value, 27x squared y cubed, and raised it to the 1/3 power. Then I distributed that 1/3 exponent to each of the terms inside. So now I can simplify 27 to the 1/3. That's 3 cubed to the 1/3, which is the same as 3 times x to the 2/3 times y to the 3/3. Y to the 3/3 is the same as 1, so you can say 3x to the 2/3 y. All right, next one. 4, and that's a square root. Since there's no number, you can assume that that's an index of 2. So I write that as 4 times 2 to the 1/2 times a to the 10/2 times b to the 3/2. Okay, now I can go ahead and simplify. I want to combine my number terms and simplify the fractions on the a and the b. So 4 times 2 to the 1/2. Remember, that's going to be the same as 2 squared. 2 squared times 2 to the 1/2. 2 squared times 2 to the 1/2. When you have two terms that you're multiplying by each other, sorry, simplifying the other ones too. When you have two terms you're multiplying, they have the same base. Remember, that means you add exponents. So 2 squared times 2 to the 1/2 is 2 to the, let's see, that's 2 to the 4/2 times 2 to the 1/2 is 2 to the 5/2 times a to the 5th, b to the 3/2. So that would be completely simplified. And then the last one, a to the 6 over 6 times y to the 3/6 times z to the 4/6. Simplifying all those fractions, we're going to get x to the 1st, y to the 1/2, z to the 2/3, and that is our most simplified form. When you are simplifying, these are the things you have to be thinking about. You can't have any negative exponents. You can't have any radicals in the denominator, so you have to rationalize them. So these are examples that are not allowed. You cannot have a complex fraction, which means a fraction over a fraction. And you must have the smallest possible radical. So square root of 40 would be reduced to 2 radical 10. And you can only have one radical, so you want to combine them into something more simple. We have now the ammunition to do all of those things. So Right answers in radical form. First you want to get them as simplified as you can in fraction form and then change them into a radical. So 4 to the 1/3 times a to the 1/2. Okay, 4 to the 1/3 is the same as 4 to the 1/6. Alright, so I'm just letting it go here while I'm talking. Let me stop and explain now. Okay, so what I did is I found the two fractions, in order to combine them under one radical, they needed to have the same index. So I went from 1/3 to and 1/2 to having 2/6 and 3/6. Now I can put them under the same radical. Now I've got a 4 squared times a cubed, which is 16a cubed all over the radical raised to the 6th power. 6th root, I should say. Okay. Next one, x to the 1/2, x to the 3/4, x to the 1/5. Think about like bases with different exponents. You're going to add the fractions together. So we want to add the fractions. We better have common denominators of the fractions. So let's find common denominators. X to the, we want the common denominator for 2, 4, and 5. That sounds like it's going to be probably 20. So the first term is x to the 10/20 times x to the 15/20 times x to the 4/20. Now again, we have the same base. Now we have like fractions, so we can add the exponents together. 10 plus 25 plus 24 is 29/20. That's an improper fraction. That's the same as x to the 20/20 times x to the 9/20, but that's x to the 1 times x to the 9/20. And that would be our final form there, x times x to the 9th with to the 20th root. Okay, I know I'm going fast, so you can pause and take a look and slow down if you need to. W to the minus 4/5, that's the same as 1 over w to the 4/5. Now we have to rationalize that. We're not allowed to have a radical in the denominator. Okay, so what are we going to multiply that 4/5 by to get that fraction out of the denominator? Now keep in mind, what we want to get is w to the 1st power. So w to the 4/5 times w to what is going to give you w to the 1st power? Well, if you multiply that whole thing by w to the 1/5, then it's going to become w to the 1st power. So I'm going to multiply the bottom by w to the 1/5, and then if I multiply the bottom by w to the 1/5, I'm going to multiply the top by w to the 1/5. So I'm going to get w to the 1/5 above and w to the 5/5 below, or 1. And so I'll end up with the 5th root of w on the numerator and w down below. Right answer is in radical form. Okay, so I got x times y to the minus 1/8. I can't have a negative radical, a negative fraction I should say, so I'm going to go x over y to the 1/8. Now I need to rationalize that. What am I going to multiply the new denominator in order to get rid of that 1/8? Well, I want to multiply it by y to the 7/8, because then that will multiply out to become y to the 1st. So I multiply bottom by y to the 7/8 and top by y to the 7/8. And I'll be left with x times y to the 7/8 over y, which is x times y to the 7/8 root over y. Okay. Next one is you have the square root of 32 underneath the radical. So let's rewrite that. That's the same as 32 to the 1/2. And I'm going to raise that to the 1/3 power. Okay, now I've got it written in fraction form. It might be a little easier to simplify. Remember when I have an exponent and I raise it to another exponent? I multiply exponents. So I'd call that 32 to the 1/6 power, which is 2 to the 5th to the 1/6 power. So I could just write it as 2 to the 5/6 power, or 2 to the 5th to the 1/6 power. And finally, 25 and to the 4th, the 6th root of that. Okay, so I'm going to say that's going to be 5 squared raised to the 1/6 power, and then n to the 4th raised to the 1/6 power, or 4/6. Now I've got the 5/2. I'm going to go ahead and multiply those two. I'm going to multiply these two exponents here. 2 times 1/6 is going to be 1/3, and then simplify this one, and so I'll get 5 to the 2/6, n to the 4/6, which is 5 to the 1/3, n to the 2/3, which is 5 over n squared, underneath the radical. Okay, now, again, we're going to be combining radicals, and when we did this last time, we knew that you had to have the same index, and these do not have the same indices. We have, this is a square root, and this is to the 1/3, or a cube root. So you can't combine them as they are, so you have to play around with the fractions and get them to have, essentially, change them into fraction form, and then get the same denominator, and then you can combine them. So, I'd say that this one is x to the 1/2 times y to the 1/3. Which is x to the 3/6 times y to the 2/6. Now that you have them with the same index, or the same fractional denominator, you can put them under the same radical with 6 as the index. So this is going to become x cubed times y squared, and that would be your final answer in radical form. Okay, take the next one. Again, we're going to change it into fraction form, and then we're going to try to combine the terms. Okay, so we got x to the 1/3 times x to the 3/4. Because we have the same base now, we can combine the two exponents. But remember, when we have two bases and I'm multiplying them, I'm going to add the fractions together. And these do not have the same denominator, so let's change them so that they do have the same denominator. That would be 4/12 times x to the 9/12. Now I can add the two fractions together. 4/12 and 9/12 will give me 13/12. And then we can further reduce that, because that's the same as x to the 12/12 over x to the 1/12 times x to the 1/12, which is x times the 12th root of x. And that would be my final answer. Okay, the 6th root of 125 times the 4th root of 25. Let's change those into fractions and see what we find. It helps to know that 125 is 5 cubed and 25 is 5 squared. So we can now write those as fractions. 5 to the 3/6 times 5 to the 2/4. Okay, now I have the same bases, so I can combine the exponents. But again, when I have the same base and I'm multiplying two numbers with the same base that have exponents, I have to add the exponents, which means I have to have common denominators. Common denominator for 6 and 4 is probably going to be 12. So I would change that to say that's going to be 5 to the, I'm sorry, I didn't even notice that. They're both raised to the 1/2 power, so 5 to the 1/2 times 5 to the 1/2. Now I can add those two fractions together and get 5 to the 1st power, and that simplifies to that. Okay. All right, x minus 4 to the negative 1/2 power. Now it gets get a little messier. We can't have a negative fractional exponent, so we're going to write it as 1 over x minus 4 to the 1/2 power. But we can't have a radical in the denominator, so we need to figure out what can we multiply by in order to get that radical out of the denominator. Well, if we multiply the top and the bottom by x minus 4 to the 1/2, then I'm going to end up with just x minus 4 down below. But if I multiply the bottom, then I have to also multiply the top. So I'm going to get x minus 4 to the 1/2 power above. I'll end up with x minus 4 to the 1/2 on the top and x minus 4 down below, which is just x minus 4's square root over x minus 4. And that would be considered simplified. Now this next one is really messy. So be patient, be neat, and be careful. Here we go. I'm going to multiply, since I have an x to the 1/3 down below, I'm going to multiply, I'm going to just change that to saying x to the minus 1/3, and then I'm going to distribute that x to the minus 1/3 to my other two terms. And I'm going to get x to the 2/3 times x to the minus 1/3 plus 3 times x to the minus 1/3 times minus 1/3, which I've already multiplied out. It gives you 3x to the minus 2/3. I can combine the exponents on the left and get x to the 1/3 plus 3 over x to the 2/3. We have a radical in the denominator still, or a fraction in the exponent, so I'm going to multiply top and bottom by x to the 1/3 to get rid of the fraction in the denominator. So x to the 1/3, I multiply that, and I got to multiply the top by it as well. I'm left with x to the 1/3 plus 3x to the 1/3 over x, or the cube root of x plus 3 times the cube root of x over x. And you cannot combine those terms further. As you get a sense, that's our last example, but lots of different scenarios here, and you basically just have to do lots of problems to practice. So this is just one where repetition will really help you solidify the rules of combining radicals. But that concludes our lecture.